Hello everyone, welcome to this video. In this video, we are going to talk about volume by Wasser method. First, let's look at the definition. Suppose y equal to f of x and y equal to g of x are continuous function on the interval ab with f of x greater than g of x and both of them are positive functions. So let's first draw these functions. So here I have my x-axis, origin, y-axis, and the functions f of x and g of x. So both of them are positive functions, and f of x is greater than g of x. If the region R, if R, the region bounded by the graph of the function, which are given here, and the lines x equal to a and x equal to b, that is from x equal to a, that's from x equal to a up to x equal to b. If this is the region R, the region R is the region between the functions and the vertical line x equal to a and x equal to b. If this region R is revolved about x-axis, we are revolving the region about the x-axis. Revolve the region about x-axis. Let's see what type of solid is formed. So let's draw that over here. So the image of the line or the graph, g of x at some point of time will be somewhere here, just like that. And the image of this function while rotating about the x-axis, it will be somewhere over here when they are reflected about x-axis. So now the solid formed will be, let's see, the solid formed will be, this will be the inner radius of the solid. This will be the outer radius of the solid on the left end. Similarly, this will be the inner radius of the solid at the right end, and this will be the outer radius of the solid at the right end. So there we have the solid formed. So this is the solid formed. You can see. Let's set it so that it looks like a perfect solid there. And this solid is not a complete solid. In fact, it is a hollow solid. You can see that there is hole in the middle. So because the cross sections, if we cut this into thin slice, the cross section will be like a washer. That's why the method we use here to calculate the volume, it is called the Wasser method. And here is the formula for that. Volume will be equal to integration from a through b, from here, that's from a up to b, of pi times the upper function is squared, or the function which is far from the x-axis is squared, minus the function which is closer to the x-axis is squared. We have to integrate this difference with respect to x. That is when we revolve the region about the x-axis. If the same region is revolved about the y-axis, if the same region is revolved about the y-axis, then the formula will be slightly different. If it is revolved about y-axis, the volume will be equal to integration from c through d. These are the values along the y-axis. Now we are integrating with respect to y of pi times phi of y squared. So now we are writing the function as function of y. So phi of y squared minus psi of y squared dy, where phi of y is the function which is far from the y-axis, and psi of y is the function which is closer to the y-axis. Now we are going to take examples and use these formulas to solve the problems. Example, find the volume of solid of revolution obtained by revolving R about y-axis, where R is the region in the first quadrant enclosed by the graph of y equal to 2x, y equal to x, and y equal to 6. Use Wasser method. So first, we are going to represent the region R by graph. So let's draw that. That's my y-axis. This is my x-axis. So we are going to label them first. X, this is the origin. This is y. Now let's draw those graphs. The first one is y equal to 2x. So the graph of y equal to 2x will be like that. A straight line, y equal to 2x. The next one is y equal to x. So y equal to x will be something like this. This is y equal to x. And the other one is y equal to 6, which is a horizontal line. So this is y equal to 6. So the region R is this triangular region. This is the triangular region R. And we are revolving this region R about y-axis. We are revolving about y-axis. Okay, so let's indicate that we are revolving the region about the y-axis. When you are revolving the region about the y-axis, and when you want to use the Wasser method, the formula is, let's write that down. We know by Wasser method, the volume is equal to integration from C through D pi times P of y squared minus psi of y squared dy. So here we need the functions in terms of y. So let's see how we can do that. Volume is equal to integration from C through D, that is the lower y value up to upper y value for this region R. For this region R, the lower y value is 0 and the upper y value is 6. So we are integrating from 0 to 6, then pi times square of P of y. P of y is the function which is far from y-axis. So from here, the function which is far, this one comes first, so that is the nearest. The second one is the farthest. So in this one, x is equal to y. So my function is y, and we are squaring that. So it is y squared minus psi of y squared. Psi of y is the function which is close to the y-axis. So when you go from here, this function is closer to y-axis. And here the function is written in terms of x. And if we want to write this in terms of y, it will be x equal to y over 2. So function in terms of y is squared. So if we square this, this will be y squared over 4. So we can write that as y squared over 4. And we are integrating this with respect to x. So let's see what do we get. Volume is equal to integration from 0 through 6. We have a pi here. 1y squared minus 1 over 4y squared divided by 4 is the same as 1/4 y squared is 3/4 y squared. So that can be written as 3/4 and then y squared dy. Now, 3 pi over 4 is a constant. We can take that out. The volume is equal to 3 pi over 4. And we need to integrate this one. Integration of y squared is y cubed over 3. Y cubed over 3. And the result must be evaluated between 0 and 6. 0 and 6. Volume equal to, over here we have 1, 3 in the denominator, other one in the numerator. And there's a multiplication sign in the middle, so we can cancel them. And by canceling, we get pi over 4. And as we plug in the upper limit, it will be y raised to 3. Y raised to 3 is there. So if we plug in upper limit, it will be 6 raised to 3. Minus, if we plug in lower limit, it will be 0 raised to 3, which is 0. The volume is equal to pi over 4 multiplied to 6 cubed is 216. The volume is equal to 216 divided by 4 is 54. The volume is 54 pi. And if we want to change that to decimal using calculator, it will be 169.65 cubic units. So in this example, we calculated the volume when this region R is revolved about y-axis using Wasser method. Next example, the region R in the first quadrant enclosed by the graph of the function y equal to x squared and y equal to square root of x is revolved about x-axis. Find the volume of solid formed. Okay, first we are going to draw the region R. For that, this is my x-axis. This is my y-axis. We are going to label this y, origin, x. There are two important functions there. The first one is y equal to x squared. The graph of y equal to x squared will be like this. Y equal to x squared. And the other one is y equal to square root of x. Y equal to square root of x. And the region R is the region enclosed by these two functions in first quadrant. So this is the region R. Now what we are doing is we are revolving this region R about x-axis, and we need to find the volume of the solid formed. So here the intersection between these two curves is 0, that's at origin. So we can write that point as 0, 0. And similarly, here is the other point of intersection. You can see we have y equal to square root of x and y equal to x squared. The square of the function and square root of the function are equal when x is equal to 1. So the x value will be 1 because 1 squared is 1 and the square root of 1 is also 1. So that means if you plug in 1 into either of these equations, y value will also be 1. The point of intersection is 1, 1. Now, as we are revolving the region about x-axis and we are using the Wasser method, let's write down the formula first. So by Wasser method, volume is equal to integration from a through b, because we are integrating with respect to x as we are revolving about x-axis and we are using the Wasser method, pi multiplied to f of x squared, that is the function closer to, function far from the x-axis squared, minus g of x squared, that is the function closer to x-axis squared, and we are integrating that with respect to x. So volume will be equal to integration from, for this reason, the lower x value is 1 and the upper x value, lower x value is 0 and the upper x value is 1. So we are integrating from 0 to 1, then pi multiplied to f of x squared, the function which is far from the x-axis. So over here, this is the nearest function. This one is the function which is far from x-axis. So that is y equal to square root of x. It is square root of x, and we are squaring it. So if we square the square root of x, that will be x minus g of x. G of x is the function which is close to x-axis. The function which is close to x-axis is this one, and its equation is y equal to x squared. So this is my function, x squared, and I'm squaring that again, so it will be x to the 4. And we are integrating this difference with respect to x. Pi is a constant as it is. Integration of x is x squared over 2 minus integration of x to the 4 is x to the 5 over 5. And we need to evaluate this between 0 and 1. So volume is equal to pi times, if we plug in 1 into this expression, it will be 1 squared, that's 1 over 2, minus 1 raised to 5, that's also 1, so 1 over 5. So it will be 1 over 2 minus 1 over 5. And if you plug in the lower limit, 0 squared, that will be 0. And then also x to the 5, 0 to the 5, that will be 0. So everything inside the parenthesis will be 0 multiplied to pi, that will also be 0. We are subtracting 0, which is equal to pi multiplied to 1/2 minus 1/5 is 3/10. So the volume is equal to 3 pi over 10, or if we simplify this using calculator, it is 0.94 cubic units. 0.94 cubic units. So in this example, we calculated the volume when this region R is revolved about x-axis using Wasser method.